So irrational numbers are a number which when expressed in decimal form, it is non-terminating and non-repeating or non-recurring, right? So irrational numbers, please note this down. Irrational numbers, the beauty is here the numbers when expressed, or these numbers when expressed in decimal form, these numbers when expressed in decimal form are non-terminating and non-repeating. In bracket you can write non-recurring. Okay. So example, pi is an irrational number. Root 2, root 3, root 4, all, not root 4, root 2, root 3, root 5, root 11, all these are irrational numbers. Then cube root of 9. You can consider cube root of 9 as an irrational number. Pi is a irrational number. But 22 by 7, the value of pi is 22 by 7, right? But we say 22 by 7 is a rational number. It is a rational number because 22 is a integer, 7 is an integer. So 22 by 7 is a rational number, but pi, the letter pi is after division what you get, that is a non-terminating, non-repeating decimal. Pi is a irrational number. Okay, so if a positive number, if you're trying to find a perfect square, say for example, I have 5. What is square root of 5? Take square root of 5. Can you find a perfect square root? Can you find a perfect
No,
square?
ma'am.
You cannot. So anything, you cannot find a perfect square root of this. You can say that this is an irrational number. If you are unable to find a perfect square root, you can call that as a irrational number. Similarly, for cube root also, the same thing is applicable. Cube root is, when I say cube root of 27, there is a perfect square root, right? Not square root, perfect cube root. 3 into 3 into 3 gives you 27. So 27 is a rational number. 27 is a rational number. But what about cube root of 28? There is no perfect cube root for 28. So this is cube root of 28 is an irrational number. Before we go ahead with the proof for root 2 is an irrational number, we need to understand what are coprime numbers. Take example of 15 and 17. Find the HCF between 15 and 17. What are the factors of 15? If I'm trying to find HCF using prime factorization method, you get 15 is 3 into 5. Whereas 17 is a prime number, so it doesn't have any other factor other than 1 and 17. So 17 is 1 into 17. So there is no common factor between 15 and 17 other than 1. So the numbers whose HCF is 1, such numbers are called coprime numbers. So any two subsequent numbers like 25 and 26, the HCF of 25 and 26, or say 35 and 36, or say 6 and 7. All these are coprime numbers. Also, take two prime numbers, say 5 and 7. The HCF of 5 and 7. HCF of 5 and 7 is again 1. That is also 5 and 7 are coprime numbers. So the common factor between 5 and 7 is 1. There are no other common factor between them. Such numbers are called coprime numbers. Take another example. Find the HCF between 14 and 55. What are the prime factors of 14? 2 times 7. So 14 is 2 into 7. Whereas 55, what are the prime factors of 55? 5 times 11. So 55 can be written as 5 into 11. So in this case also, there are no common factors between 14 and 55. There is no 2 coming here as factors, and 7 is also not appearing in as factor of 55. So in this case also, HCF of 14 and 55 is again 1, since there are no common factor other than 1. So 14 and 55 are called coprime numbers. Question is, prove that root 2 is irrational. Root 2 is irrational. So here we are using something called proof by contradiction. So proof by contradiction means we will start with saying root 2 is rational. We start saying root 2 is rational. And as and when we progress, we show that, okay, it can't be, it is not showing the behavior of a rational number, so it is a irrational number. So that's going to be our approach in this proof. Okay, what did I say? We are going to start with contradicting statement. The contradicting statement is root 2 is rational. That is the statement we are going to start with. Okay, we say it proof by contradiction. So let's start with the proof. Proof is, if possible, like that we start. If possible, let root 2 be rational. Okay, and its simplest form be a by b. So any rational number has a form p by q, right? So here, instead of p by q, we are taking a by b. So we are going ahead with the simplest form a by b. Now, the simplest form is, there is no common factor between a and b. So a and b are coprime numbers. Coprime means what? There is no common factor between a and b other than 1. Simplest form means I cannot divide it further. In other words, we call it as a and b are coprime. Coprime. Okay, this you just need to understand. You don't need to write all this. So a and b are coprime. There is no more common factor between these two numbers. Then a and b are integers and have no common factor. No common factor other than 1. Other than 1 and b not equal to 0. Root 2, I am writing it as a by b. Take the square. Okay, square both sides. Squaring both sides. What do you get? Squaring both sides, I am getting
2 is equal to squared
a square by b.
A square by b square, which I can write as 2b square equal to a square, right? 2b square equal to a square. Square is some number which is 2 times b square. Can I say that way?
Yes.
It is a square is some number which is 2 times b square. Correct?
Yes, ma'am.
So when a square is some number which is 2 times b square, don't you think a square is an even number now? What do you think? A square is an even number or not?
Yes, ma'am.
So this implies that a square is a even number. Okay. This implies a square is an even number. When you find the square of an even number, say for example 4. 4 is an even number. You take the square of an even number, what would be its result? Is it going to be an even number or it's an odd number?
Even number.
It's going to be an even number, right? So this you have understood that a is an, so a square is an even number, you understood. So when a square is an even number, this implies a is an even number, right? So a square is an even number. How did you understand? A square here, a square equal to 2 times b square. 2 into 3, 2 into any number is always an even number. That is the reason why a square, we are assuming that a square is an even number. Okay. So when square number is an even number, its square root is always an even number. So here a is an even number. You understood that a is an even number. Why? Because maybe in bracket I can write, since a into a will what is it? A into a will give an even number if a is even, equal to 2c, where c is some integer. 2 I get as a square. What will be a square?
4c squared.
It is going to be 4c square. Okay, yeah, a equal to 2c. Now what is a square? A square is, take this, a square is 2b square, right? A square equal to 2b square. In the place of a square, can I write 2b square? So I am writing in the place of a square. Maybe I can write this is 1, substituting the value of a square. Substituting the value of a square from equation 1. So here 2b square equal to 4c square. Understood? Am I getting b square equal to 2c square now? 4 divided by 2 gives me 2c square, right? What I started with is, we got 2b square equal to a square. That shows that a square is an even number. If a square is an even number, then a has to be an even number. So when a is an even number, you can express a as 2c because
2c.
it is an even number where c is
And
some
a square
integer.
will be 4c square.
Then a square is 4c square. So now bring in the place of a square, you bring in 2b square, which we have already proven somewhere here, right? 2a square is 2b square. So bring in 2b square. So 2b square is 4c square. Now what is b square? B square is divide this
This will be
by
2c.
2.
Divide this
2c
by
square.
2.
Yes. So
You
you
get
are getting
2c
2c square, right? So now you have got b square is 2c square. Now what is this b? What is ultimately we have proved b as? Again, b square is an even number. That's what we have shown, right? See, b square is 2
Yes,
times c square. What does that mean? Again, b square is an even number. That's what we have shown. This implies that b square is an even number, right?
Even
B
number.
square is an even number. That means b is an even number,
Even number.
right? So you
Yes,
can,
ma'am.
so a is an even number, b is an even number, right?
Yes.
You're getting what I'm saying? So what we have shown is A and B are even number. So now 2 is a common factor of A and B. Thus 2 is a common factor of
A and B.
A and B. I hope you're all getting me. So thus 2 is a common factor of A and B. But this contradicts the fact that A and B have no common factors other than 1. Yes or no? What did
Yes.
we start with?
Yes, ma'am.
A and B have no common factors. So don't you think this is contradicting? So you should write that. But this contradicts. You write those statements, but this contradicts. This contradicts the fact that A and B have no common factor other than 1. So the contradiction arises by assuming that root 2 is rational. Hence, root 2 is irrational. That's all. Got it? So why did the contradiction came? Because we assumed root 2 is rational, right? And that was the root cause of all the problem. So we just assume that no, root 2 is not rational, root 2 is irrational, and that's it. Okay, so that's the final statement. The contradiction arises by assuming that root 2 is rational. Hence, root 2 is irrational.